Hi everyone, welcome back to the trending topic session. This is the second part of the trending topic session where our speaker and our panelists will talk about AI and the teaching of science. Not only do we have a renowned expert, Professor Andrew Cohen, who will be doing a sharing in the later session, we're also very excited to have two laureates, namely Professor Roger Blanford and Professor Erhu Hrushevsky, who will be speaking at a panel discussion co-hosted by two promising local scientists, Professor Anderson Shum and Professor Yun Xiaoming. So without further ado, may we have the honor of first inviting on stage Professor Anderson Shum, Professor of Department of Mechanical Engineering at the University of Hong Kong and President of the Hong Kong Young Academy of Science, to say a few words for us. Let's welcome Professor Shum.
Good afternoon, everybody. It makes me a bit nervous speaking in front of so many world-class researchers and laureates, and of course, a lot of very energetic, dynamic, and curious students. I think on this topic today, this section is on AI and the teaching of science. So I think just like many of you, this is a topic that is new to me. I am a student as well on this topic, and I look forward to learning from all of you as well as other laureates. And first, I'm really grateful to have the opportunity to share a few of my own thoughts. We can discuss further later. As many of you may have heard in many of the events during this past week, Hong Kong is aspired to become the international innovation and technology hub. So talents is the key, and as you may have heard from our government officials, Hong Kong has been putting in a lot of efforts in attracting talents, and also it's very important for us to develop our own talents. And in talent development these days, I think artificial intelligence, the topic of this section, cannot be overlooked. So therefore, it is great that we can talk about this topic. For me, artificial intelligence seems to be a big wave that has been hitting us in the past year, and a lot of times we may not be able to respond after a lot of systematic and detailed analysis of the strategies. And so a short summary of what I experienced in the past year or so is that AI represents 5 things. One is AI itself is a very important research topic. This research topic can be related to the analysis of text, so ChatGPT and a lot of other systems you may have seen. Pictures, a lot of the artworks, graphics can be designed very quickly using AI. Music and many others. So as a research topic. Number 2, to me, AI is also a tool for everyday use. A lot of people are now, I know, are using it for preparing speeches, for answering questions. If you're a government department, if you like to go to a government department and ask some quick questions, rather than waiting for some physical people to answer you, some departments may be very good at using AI for them to go through their database and answer your questions. That could be very useful. Of course, face recognitions and many others. And third, AI is also very important research tool. This research tool is highly interdisciplinary and cross-disciplinary. Very often, AI can cross with other fields, such as in designing drugs, in microscopy. Maybe in the past, when we do microscopy, we have to first take the picture and relies on an expert to tell what they are. In future, maybe AI can tell you what you are seeing, maybe even real time. So that is a very important tool. Design of new materials, molecules, etc. So it's a very powerful potential research tool. And fourth is also a very important teaching tool. So I was interacting with a lot of our colleagues, maybe in a lot of disciplines where you have to train students to interact with other people, like patients. For example, in the profession as nurses, etc., you have opportunity to train the students by getting them to interact with an AI, with generative AI people, so they can get well trained before they get too nervous interacting with real people. And of course, it's very important for, in future, maybe we can use it as a translation tool when we go on holidays to countries where we don't speak their language. The translation, and also we can get very useful results very quickly. And the 5th point I'd like to emphasize is AI can also be a very important dissemination tool of science. In future, I don't know how AI or some of these technology would mean for scientific publications. Maybe there will be more effective and new means to communicate science, to review science, and to evaluate science. And all of these means that it's very important for students nowadays to be literate in AI. So what does AI literacy means for students? First, in terms of the concept, so an AI literate student, I think they need to first understand what the thinking behind AI is, what is the concept, some basic terminologies, for example. And second is in terms of the applications. Maybe there are some common AI tools that you cannot not know how to use. Just like right now, there's a lot of tool for writing documents, for making presentations. In the future, some of these tools are very essential for our students. And the third thing that we need to know, or we need to think about, is how to distinguish between the hype and the reality in the AI world. What are some of the realistic expectations of what AI can do? What are some of the limitations of what AI cannot do? Without such knowledge, sometimes students may not be able to make the right judgment on whether this is something that they can rely on AI or not. Fourth is, of course, the safety and security, because AI also comes with a lot of its own peril. How do we control something that we don't have real control? How do we protect ourselves, and how do we make sure that the science that's being done there is right, and are there ways to evaluate? And of course, it's very important that we become very responsible users of AI tools. So take steps to address some of the limitations of AI systems and admit some of the ways that we have been using AI in some of the works that we've done. And of course, there are also risks such as involving privacy and involving fear as the AI age comes very quickly. How do we position ourselves? How do we make sure that we are not falling behind? How do we make sure that we are making good and reasonable use of it? And how do we put in data that are accurate so that our AI systems can do what they can do? So I think I like to end with saying that I think developing a proper understanding and appreciation of AI for scientists and for science students is both important and inevitable, particularly on this topic for teaching science. And I hope that the audience will maybe including myself, continue to explore the implications of AI in teaching science. Some of these may involve evaluations of students, facilitation of student growth. How do we use AI? What can we not use AI? For example, can we use AI to develop students' interest in science? Can we use AI to stimulate the development of their scientific intuition and instinct? And how do we ask the right questions? So I think my time is up, and I just like to open up the floor so that we can get ready to hear from a lot of the experts, starting with Professor Cohen, and then also our laureates. So with that, thank you very much, and look forward to discussing with all of you.
Thank you so much, Professor Sham. Please be seated. Thank you for drawing open the curtains on the discussion of AI and the teaching of sciences. Up next, I would like to introduce you to a very special guest this afternoon. We have Professor Andrew Cohen. Professor Andrew Cohen is now the director of HKUST Jockey Club Institute of Advanced Study and chair professor of the Department of Physics from the Hong Kong University of Science and Technology. Apart from being a distinguished researcher, he's also well known as an award-winning science master with a strong mission to promote science and technology advancement. And more importantly, he has a deep interest and knowledge in AI development, the person to hear from for this afternoon's topic. So ladies and gentlemen, let's put our hands together to welcome Professor Cohen.
Good afternoon. Really, it's a great pleasure to be able to spend a few moments with you this afternoon talking about a subject that I think you may already realize is somewhat controversial with lots of different opinions. Let me say at the outset that I am something of a dilettante in this area. Like many of the other researchers who are here today, I spend a good fraction of my time engaged in education, and so I have played with these tools a bit, and I want to share with you some very simple observations and hopefully some deliberately provocative opinions to foster the conversation as we move forward. I'm a physicist, so my remarks will be primarily regarding the use of AI in education in the physical sciences, but I will try to be clear about those aspects that I think might generalize to other areas of natural science and perhaps beyond. So let me begin with, as I said, a slightly provocative. Please ignore what you see on the screen there. I'm going to make three predictions on three different timescales. So first, I'm going to suggest that on the short term, the impact of AI will be rather small and mostly neutral or slightly negative. On the medium term, I think the impact will be more positive but not revolutionary. And then in the longer term, well, of course, the impact is unknown. I think it is likely to be transformative. Now, let me be clear, transformation isn't always good. So let me begin with a couple of disclaimers. So first, as has been said quite frequently in various contexts, making predictions is hard, especially when they're about the future. So you should take everything I say with a very healthy measure of salt. Secondly, the conversation about AI over the past few years is really about a very specific development, that is so-called large language models, which take a statistical approach to AI. And to be very clear, AI is a much broader subject than just that. And, AI has been an important subject for half a century. And in fact, in the early days of AI in the 60s, the statistical approach was largely ignored as being unsuitable specifically for natural language processing. And with ideas from Noam Chomsky and others, there were lots of good arguments why the statistical approach would never be successful. And surprisingly, those non-statistical approaches kind of hit a wall and weren't making a lot of progress. And remarkably, in the past only 7 or 8 years, the statistical approach in the form of these large language models has come back and really taken over everything. So I just want to be clear that a lot of my predictions are driven by the timescale for which I think we go beyond large language models and statistical natural language processing and start incorporating some other things. And I'll be very specific about that shortly. Let me preview a conclusion which I will flesh out a little bit later, which is that given that what is really going on right now, the most significant developments are in large language models, we as science educators should be leaning into that. that is really, I think, the applicability of AI in science education is because of the linguistic, the language abilities, and what we can make use of those. So I'll be specific about that in a minute. Okay, so to get things really going, let me start with that short-term impact by asking, so what's been going on just in the past year or two in physical science education and the use of AI? Well, I think one impact that we're all very familiar with, because it's been in the headlines of newspapers, is the impact, both in science and non-science education, of the use of AI in assessment. The use of AI in examinations, sorry? Okay. Can you help me with this? I want to go back. It's not going back. Nope. Okay, so while you do that, so of course, in Hong Kong, famously, when the most recent incarnation of ChatGPT became available, there was an instant response from the local universities, with most of them banning the use of AI for both students and teachers. There were one or two notable exceptions that at least sort of quietly embraced AI by allowing the faculty to choose how they would use it. But the concern, of course, was driven by largely, I think, a misguided notion that students will cheat by using AI to produce their work product rather than doing it themselves. That is something that I don't think is a real worry, especially in the sciences. It's rather easy to work around. But I would love to show some slides now. There we go. Can we go? Thank you. I have to be in control. I understand. Previous page was not working. Okay, there we go. So I just want to give you a few examples, and they are mathematical. Do not worry about the mathematics. There is no need or expectation that you will understand any of the math here. There will be no quiz, and of course you could all use ChatGPT to solve it anyway. So I have a friend who is teaching a course in mathematical methods in physics for advanced undergraduates, and he gave a few homework assignments without thinking about it, the same kinds of assignments he's given for many years, and then he said, hey, I wonder if ChatGPT can do this. And so here's an example. He had a not totally trivial double integral, and he asked ChatGPT to do it, and he got a perfect answer. This is a similar one, another kind of integral, and once again, ChatGPT did the integral, pointed out that there's no closed form for it, and suggested that you might want to do some numerical work to evaluate it, and actually said what the value is. So he was a little bit surprised at the ability of ChatGPT to do that, and I think he then did something which I think is a little bit more interesting. So on the final exam for this course, I'm going to just flash the slides, and those of you who know some elementary mathematics will recognize this as a very typical sort of undergraduate mathematical physics example. Mostly I just want to show you that these are non-trivial questions. You know, they require a small amount of mathematical sophistication. So first, second, you get the idea. Third, so the exam, if you watched when I flashed that, you add up those points, it's worth 30 points. The students, about 35 students took this exam, and the mean was 19. So the instructor, a very well-known physicist, asked ChatGPT to solve it. I'm not going to bother showing you the solution, but he simply took the material that you see on the slides here and typed it into ChatGPT. And ChatGPT came out with a solution set about 7-8 pages long, and he gave it to the teaching assistants and said, here's a late assignment from a student, please grade it, without telling them that it came from ChatGPT. ChatGPT scored a 27, significantly better than the mean for the students. But I think more importantly, the teaching fellows had no clue. They were unable to distinguish what ChatGPT produced from what the students produced. In particular, there was language in it. It said sentences, and now we do the following, and all of the language was perfect. In fact, in many ways, it was better than some of the students who are not native English speakers. So I think that this is pretty instructive. I don't think it leads to an obvious conclusion that, well, assessment no longer works in physics, because this is easy to work around. Of course, we can give in-class examinations. You don't have the opportunity to do ChatGPT. But the fact that ChatGPT can do this, I think is actually problematic from a pedagogical perspective. So, of course, things like search and the World Wide Web have been with us for decades now and did significantly transform both assessment and the way students learn things. Previously, you could have searched for these kinds of problems and how to solve them. And it's actually not very hard, and even 10 years ago, you would get pretty good answers. You would get a tutorial on how to solve a linear second-order differential equation subject to boundary conditions. But you couldn't get a search from Google or Bing to actually produce the full solution. You just get the technique for how to do it, and then you'd have to do it yourself. So one of the challenges now is that you present some problems of these sorts to students, they're likely to use ChatGPT to solve it, and you've removed any kind of cognitive engagement. They just see, okay, here's this solved problem, as opposed to having to struggle a little bit with themselves, following some kind of algorithm, understanding the various steps involved. So that's one of my reasons for saying that the short-term impact, I think, is slightly negative. Now, I don't think this is really a devastating blow. It's a criticism of how these tools might get used now, but it's really information for us as educators that we have to rethink how we structure assignments to the students to maintain that real cognitive engagement with the material to help them learn as opposed to just help them how to get to a solution. Of course, outside of the physical sciences in the social science, humanities, and the like, it's a much bigger problem, but I don't think we face that kind of problem. I will say on a positive note that these large language model-based AI is producing a vastly more efficient search tool than what we're used to. So this, as a simple example, you can find not just the technique, but you can find worked examples with no effort whatsoever, whereas that was significantly more difficult prior to the integration of these large language models and search tools. And that's important for a variety of reasons. It's not just pedagogically more efficient, but it helps in the democratization of science education. It makes a lot of cutting-edge science and techniques available to a much broader audience. It removes some of the economic barriers, it removes linguistic barriers, and that's incredibly important. And I think that that's a really important way in which this kind of advance is going to make an impact globally. That ability to interact with the information in a different way is at the heart, I think, of what's going on with ChatGPT and where we should be looking for what might happen in the future. But before I talk about that, which will be really the main part of what I want to say, there's something I just can't evade, which is this question of the reliability of the responses that you get from AI and what's known in the trade as hallucinations, especially. So let me give you an example. I put myself from the point of view of a young person who's interested in fundamental physics, my field, and I asked, this is actually Bard rather than ChatGPT, I asked, what would it look like if you fell into a black hole? And got the following rather entertaining response. So it begins with, well, what you would see as you fell into a black hole would depend on the size of the black hole and your distance from it, which I think is pretty reasonable. That's a good place to start, that there's no generic answer. As you approach the black hole, you would see the light from the surrounding stars and galaxies being distorted and lensed by the black hole's gravity. Well, I'm a little skeptical of that. This would cause the stars and galaxies to appear stretched and distorted, and the sky would appear darker and darker. I'm pretty confident that's not right. But it gets a little worse. As you got closer to the black hole, the gravitational waves would become stronger and stronger. This would cause you to feel very heavy, and it would become difficult to move. Well, that sounds more like the outcome of the Shaw Prize dinner than of falling into a black hole. You would also start to see the black hole itself. It would appear as a perfectly black sphere with no light escaping from it. Also, those of you who work on black holes are chuckling now, probably. Okay, now we get to the really difficult part. As you cross the event horizon of the black hole, you would be unable to see anything outside of the black hole. This is because the event horizon is a point of no return. Light cannot escape from within the event horizon, so you would not be able to see anything outside. Well, that's backwards, right? So that's just nonsense. And you can try to figure out how did ChatGPT come up with this answer. But that's the fun part of large language models. You get weird answers, and you have to sit there and think, well, it's statistical, so what was the statistical information that let it decide that light can't go into the black hole when you fall into it? Finally, there is some spaghettification, which those of you who might watch Marvel TV shows have learned about, but I'm not sure that that's an actual physical phenomenon. And then finally, something that I find perhaps the most egregious part of this answer, the last sentence here, that it is important to note that we cannot know for sure what would happen to you if you fell into a black hole because we can't observe the inside of a black hole. Well, that's just terrible. I mean, that is such an incorrect view of how scientific discovery works. I think someone who reads this answer comes away less well-educated than before they looked at it. So, okay, often we hear from many people that this is why we can't use AI at all because it produces garbage like this. I don't think that's fair. I think that, of course, you can search on the internet, you can find all sorts of garbage. And part of the challenge that is a necessary part of education these days is how you use these tools. They are tools, and that it's a responsibility of the user to help assess the validity of the information that comes out and not just accept it as gospel. And there are specific techniques that we can use to do that. The one thing I do want to point out is that the reliability of these large language models depends a great deal on, well, how common the questions are. The more information, the more common they are, the more likely they are to give actually reasonable answers. And so that's especially problematic for science, because we might be asking those questions for which, well, of course, scientists ask the questions for which they do not know the answer. If you know the answer, it's not part of science anymore. And so that's where there's less good information and all sorts of crazy things on the internet. And I have a ton of searches, if you're interested, which I can show you about asking questions about, where do neutrino masses come from and what happened before the Big Bang. And the kinds of answers you get there are, well, they're fun after a drink or two, but not very useful for pedagogical purposes. So I do want to make one more comment before I move on to more positive things. About one of the problems I see with this whole approach to science education is that these large language models are statistical. They're next word predictors. You have a sentence, and then there's basically the transformer network or whatever you're using tries to figure out the distribution of probabilities for what the next word might be on the basis of the training set, which is the internet as a whole. And that's not really a good way to think about science or to get reliable answers out of science. We are not a statistical problem. And I think, a lot of the advocates for AI, large language model AI in particular, for science, misunderstands this. That they think that there's magic somehow in the statistical approach, which it is truly remarkable, and I'll show you some examples of how remarkable it is in a minute. But that's a misunderstanding of how science works. Science is not about consensus directly. We appeal to nature. We do experiments. We can, in my field, for example, there was an idea called supersymmetry, low energy supersymmetry. And 90% of the physicists were convinced that this is the way nature works to solve a few problems and would be discovered in an experiment, and it didn't. And if you had used ChatGPT 15 years ago, it would have very confidently predicted this is the way the world works. And it'd just be wrong. The consensus was not right. In addition, it sort of reinforces this view that you appeal to authority, which is a huge problem in teaching young people about how science works. We don't ask Einstein what he thought about gravitational waves. That would not be a good way to learn about gravitational waves today. We don't appeal to authority. We know so much more now than we did then. And unfortunately, not only is that a challenge for large language models in producing answers, but it's problematic in that it tends to encourage students to misunderstand the way science works. And I think that that's one of the big issues. In fact, this is a big issue, I think, in science education in general, that especially in secondary education, we're cramming lots of facts about the natural world into the heads of students, but we do a much less good job of explaining how science works. Where science isn't about facts. It's about observations and coming up with ideas and not knowing what the answer is, exploring those ideas. And I think that ChatGPT reinforces this view of, well, you ask questions, there are factual answers, you get those answers. And I think what's really lacking here is some engagement with the actual practice of science as opposed to just the results of science. And I'll make some remarks about that in a minute. Okay, so I've been pretty negative for the past 20 minutes. I have 10 minutes remaining. So I did say I had some optimism. So where does the optimism come in? Well, I want to make a very imperfect analogy with the introduction of calculators, which those of you who are old enough to remember education before calculators and after calculators, there was at least equal concern for the introduction of calculators as there is today for ChatGPT. It's going to destroy the ability of young people to do any kind of arithmetic. They'll never learn mathematics. They won't understand anything. I don't think that's happened, first of all. But I do think that some things have happened. So one thing for which there's a great deal of evidence is that the numeracy of young people today is far worse than it was prior to the introduction of calculators. And I think those of us who teach at the undergraduate level are very familiar with that. It's hard to know whether this is related to the introduction of calculators. So for many years, I taught a course in scientific quantitative reasoning for non-scientists. So I have seen probably 1,000 students over the 4 or 5 years I taught that course come into the classroom and try to teach them how to think about numbers. And the first thing I learned is that they have no sense of what numbers are anymore. They don't understand, especially in the use of science, they don't understand uncertainty. They don't understand accuracy. So famously, I guarantee you, everyone in this room, if I say, what's the acceleration of gravity near the surface of the Earth? You're going to say 9.8 meters per second squared. All of my non-science students, literature majors, business majors, they all know 9.8 meters per second squared. And so I asked them, well, is it 9.8 meters per second squared exactly everywhere? And usually I get a lot of head nods like this. And I say, well, no, it varies from place to place. And they're a little bit surprised because they thought that this is some kind of law of nature, 9.8, this very specific number. So that's a problem. And then I could never convince them that, for most purposes, using 10 meters per second squared, which differs by 2%, no one is really going to care about a 2% difference in a final number. And that's unacceptable because they're so used to punching numbers into a calculator and worrying about the least significant digit being right, that their sense of on an examination, they have to get it right, that last digit must be right. And that's a huge problem. And I think that's a change, and I think that's in part due to the use of calculators. Now, I'm not opposed to the use of calculators. I think the use of calculators is great because when there is challenging arithmetic to be done, it's a waste of time to force our students to focus on that as opposed to on the science that we're trying to teach them. But it's important that we recognize that the use of this tool has to be managed properly, and we have to emphasize talking about the things that matter, what the numbers really mean, why we have quantitative views of science and the like. So I think the one way to think about the use of AI currently is it's similar to the introduction of calculators, where the calculators freed students from having to think about complicated arithmetic, which, at least for good educators, allow us to focus more on the things that do matter. Well, calculators are good at arithmetic. Large language models are good at language. And so really, I think what's important is that we should be leaning into that what the large language models do for us is nothing good for science directly, but they change the way we can engage with search, for example. And so let me give you an example, actually from a colleague of mine who was not a gravitational wave expert, but as you probably know, gravitational waves have been a very big deal over the past decade or so, and wanted to just play with some of the data and be a student himself. So he asked ChatGPT-4 in this case, can you just write a Python program that will help me analyze some of the gravitational wave data? And the answer was actually some pretty decent discussion of it's a complex task, there are various aspects to it, fast Fourier transform, but it ended with, okay, here's a simple Python script to do it. You'll notice in the penultimate paragraph here, it says you need to download the data. So he was annoyed, and he said, can you download it for me? Why are you wasting my time? And of course, ChatGPT is very polite. So absolutely, and it explains what it's going to do, and then produces a modified script that downloads the data for him. Okay, he was a little bit annoyed that it was just doing this fast Fourier transform, wasn't doing anything more sophisticated with the data, that was a little too simple, so he just said, can you do something more sophisticated? And it gave him a new Python script with a description there which is not very important, but actually is fairly sophisticated in what it can do. Now, by the way, what is ChatGPT doing? It's looking on the various gravitational wave experiment websites where they have packaged Python scripts and things like that. And looking at them and modifying them, it knows Python. Its Python is better than me. And does this. So it came back with some Python code that I haven't showed you, and I ran the Python code, and this is what came out. It's got an error. And so I did nothing but copy and paste the error back into ChatGPT, and it, of course, politely apologized for its error and fixed it. And it worked perfectly. Okay, so the key here is that I could have gone to one of the gravitational wave experiment websites where they have tutorials, they have a lot of material, and I would have gotten to this point, but it would have taken me much longer. And the key here is the way that I can engage through the language. It's my ability to talk to ChatGPT. It's not doing anything I couldn't have done in a different way, but it's very efficient, because I can just say, no, that's not right, can you fix it? And it does. All right. So I think that is quite remarkable, and I think that there's a lot of opportunity here. So let me just, in the 1 or 2 minutes remaining, talk about some of those opportunities and then speculate wildly on something that might happen in the future, but will take a lot of time and effort on the scientist's part. So first, I think leaning into this language part has a lot of good opportunities for enhancing the support for instructors, not just the students. For example, one of the things I've been playing with, as you might know, some of the large language model tools, you can tell the large language model that you want it to behave in a certain way. And it will produce a slightly modified large language model that has certain characteristics. So I have said, can you behave like an 18-year-old student with an interest in physics? And it does that. And you can have a conversation. So for me, that's been incredibly helpful, because I get some feedback on the kinds of confusions, the kinds of questions that that 18-year-old might have, which helps me enormously. It's not fantastic yet, but it's getting there. And I think that's an important possibility. It's good at very mechanical tasks, creating a syllabus, making an exam, making a course outline, things like that. I'm not so impressed by that. I think it's also very helpful for feedback, that you can use it I have given a lecture, and I didn't for this one, sadly, I'm sorry, but I gave a lecture to ChatGPT and asked it to criticize it. And it came back with some pretty interesting suggestions. Some of them nonsense, but some of them were worthwhile. And so I encourage you, the next time you're going to give a lecture, give it to ChatGPT first and see what happens. Clearly, there are lots of elements of this which will support student learning. We already talked about democratization, access, and things like that. But there are various other things that are maybe not completely obvious. One is a removal of judgment. Students may be embarrassed to ask you a question because they don't want to appear dumb. But they're perfectly happy to ask ChatGPT the question. And so I think that that's something that we need to recognize. All of these things aren't science-specific. Okay, so I said I focus on natural science, but most of these things work even if you're not in the sciences. But I think there's a lot of opportunity. Now, in the 40 seconds remaining, what do I really want from a large language model? And maybe someday it'll happen. Science education, I said before, is the thing that's missing is that usually we have to spend our time teaching techniques, teaching background information, but not teaching how science is practiced, how we do science, that idea of discovery where you don't know the answer. Well, we can tailor these large language models. We can say, behave in a certain way. Ideally, I'd like to be able to take a large language model and say, hey, behave like the universe, lambda CDM with these parameters. But don't tell me what, I'll tell you what the parameters are, and then I give it to a student and say, okay, you figure out what model I put in. Just by interacting with it, saying, okay, do the following experiment, it comes back and says, here's the result I would have gotten by doing that experiment, including noise, uncertainties, all of that. Giving students an artificial universe that they can play with. And of course, I picked cosmology, but you can imagine doing this in any kind of science endeavor. And I think that we're not close to that now, but I'm pretty confident that we can get there at some point, probably in my lifetime. And I think that that would really be transformative in science education. Okay, so my time is up. I think I'm at exactly 0. Thank you for listening to my random thoughts, and I look forward to the panel discussion.
Thank you very much, Professor Cohen. Please be seated in the audience. Thank you. Well, in the upcoming panel discussion session, we shall be inviting not only our panelists to discuss, but as usual, we would be expecting questions from you. So either you could raise your hands if you have a question for the panelists, or utilize the HKLF app in the Q&A session. Post your questions to the panelists if you have one. Now, I would like to invite our panelists and our co-hosts to come forward to the stage. And let's welcome, first off, Professor Roger Blanford, 2020 Shaw Laureate in astronomy and professor of physics, particle physics, and astrophysics at Stanford University. Professor Blanford, please. Welcome. And up next, Professor Erhu Hrushevsky, 2022 Shaw Laureate in Mathematical Sciences and Merton Professor of Mathematical Logic of Merton College at University of Oxford. Welcome. Let's also invite on stage Professor Yun Xiaoming, Head and Professor of Department of Mathematics at the University of Hong Kong and founding member of the Hong Kong Young Academy of Sciences. Welcome. Last but not the least, once again, Professor Anderson Shum to come forward to the stage. Welcome, gentlemen. And for this panel discussion session, we're honored to have Professor Shum and Professor Yun to co-host for us. So, professors, the stage is all yours.
Good afternoon. Good to see everybody again. I'm really honored to be on the same stage with two leading scientists who are with us in Hong Kong today. So I guess from Professor Cohen's talk, we got a lot of very interesting examples and episodes on what teaching science using AI may mean for the teachers and for the students. And certainly there are a lot of lessons to be learned. And may I start by maybe inviting one of our laureates to share your thoughts on whether you think in future you will be using AI to teach science to start with.
All right, I'll go first. So I'll go first. I should go first. I think the answer has to be sort of generically yes. And in some sense, I think at some level we already are You say emphasis on ChatGPT, and my university told me, I think a couple of courses ago, tell the students not to use it. And I did, and they said, you're too late. So yes, I mean, it's part of it's already part of the scenery, and I think it will be more so. And of course, as Professor Cohen just eloquently discussed, how that happens will be interesting and very important, and we have to get us. I'm not sure if we're capable of getting ahead of it, but to not trail too far behind.
I think I have my own.
Oh, you have your own, yes.
Phone, yeah. I mean, first of all, I would like to say that I'm a complete dilettante in these matters. I really have no expertise in it at all. I really take to heart what Professor Cohen said about it's very, very difficult to predict the future, especially at a time like this when something really new is happening. So it's true that a certain component of what's happening in large language models is statistical, the learning process is statistical, but beyond that, in the end, we get some kind of polynomial, with max in it, some kind of expression like that with billions of parameters that have been found statistically, but then this polynomial is able to answer, to have an intelligent conversation with you. So there's something really new, and the first computer revolution, maybe in the 40s, when computers started becoming important in our lives, came after a few decades of intensive theoretical prediction of what a computer is, what an algorithm is, what can you do. And the same people who thought about it theoretically were involved in the first computers, so there was a lot of preparation. And I think this is why I was invited here, because I'm a logician, and somehow computer science emerged to a large extent out of logic. But today it's completely different. It's not preceded by theory, at least as far as I understand. We've suddenly observed something totally new, and it'll take some time to have the first ideas about how it's really working. So instead of, I don't know, maybe I'm taking too much time with this, but I thought, should I continue or?
No, I think this is just warming us up and warming the audience up, and I think during this section, our audience have heard a lot from teachers who have spoken on this view. So we are welcoming a lot of questions from our students about your wishes, your thinking about what you'd like to raise or what you'd like to ask our panel members on this very interesting topic as well. So if you have any questions, please feel free to raise your hand or type your question in the Q&A, and we'll be able to see it. So maybe with that, I'd like to also pass the floor to Professor Yun, who's also head of Department of Mathematics, and to follow up on what Professor Gurowski just mentioned.
Yes, thank you. So very excited to see so many laureates, and especially some very great mathematicians here. I am an applied mathematician, so my research is very relevant to AI. So I use a lot of AI techniques and the knowledge in my teaching. So I feel actually AI for me, for my teaching, is first of all, it's a tool. It's give us a lot of new tools to analyze some applied mathematics like algorithms, something like this. And also it's a inspiration for students. I felt actually in the past few years of late, I felt a lot of inspirations from students because of AI. When I integrate some AI components in the teaching, immediately some students will feel more interested in math. And also, I feel for graduate students, if I'm teaching some, advanced courses for PhD students, and I can immediately actually inspire the student to come up with some idea or some new topics for research from AI. Like, for example, I'm not sure if you know the stable diffusion model, something like this. And then the student will, some of my students, they are trying to analyze how the stable diffusion works. and they want to, explore the model, explore the algorithms. So for me, actually, AI helps a lot for teaching, and it makes my teaching much more attractive to students. Yeah, that's the first thing I want to share with you. Thank you.
Maybe I'll just say that I haven't used AI yet. My students probably do, and indeed, and I think that's a very good thing. So many things that they would maybe ask me with some hesitation, they ask ChatGPT with no hesitation, and maybe it's also a good thing that they learn that not all answers are correct, and they cannot trust them, and they have to check further. Yeah, but still going back to predicting the past, I just want to say what has been the impact of just the understood computer revolution of most of the 20th century on my teaching and my research. Because the answer may be surprising, because we know it's changed every aspect of our lives, and certainly many aspects, well, of course, applied mathematics has been completely transformed, and many aspects of science. In my area of pure mathematics, the effect has been almost zero. It's been in peripherals, it's been enormous, yeah, so okay, we write on, we don't handwrite anymore, we do it on a keyboard, and we almost don't go to the library anymore, we don't spend hours in the library because we can get it in our office very quickly. So it's a huge effect comparable to the invention of printing or something like that. But in the core, in the heart of mathematical research, where do the ideas come from? There's been just no change. I mean, computers have not entered into it. And for me, I've made some experiments which were not particularly successful. Maybe I just wasn't good at it. But for me, in teaching either, I mean, in the central aspects of teaching, of trying to convey to students not just the textbook, but somehow the way of thinking about the notions, what's important and what's routine, what's striking, that kind of thing. Yeah, I mean, I don't see that there's much difference between the way I teach something and between the way it was taught in Plato's Academy, probably. Yeah, this is about the past. I don't know what will happen.
Have you heard about actually Terence Tao is actually working with ChatGPT for research? Have you heard about this?
Yeah. I don't know the details. I know that he's very interested in developing it. Yeah.
Some of my colleagues told me actually for algebra in pure math realm, actually ChatGPT can, AI can actually, or ChatGPT machine learning can help for algebra in pure math.
Yeah, so specifically ChatGPT, yeah? Yeah, I don't know what it, yeah.
If I could try a comment on this. I teach mainly physics and to some extent astronomy, and so I have a very different style, obviously. And so I'm kind of my own experience, sort of going backwards, especially with AI itself. I think I lived through two alleged AI revolutions, which were going to transform science in the way that we observed. And I think, and I knew some of the people who were involved in it, and they really were, from the perspective of the science I know about, basically duds. I mean, I knew people who were doing adaptive optics, for example, and they said, this is the way to do it, we'll do it. And after about a year's really hard work, they said, I give up. I'm going to just invert a matrix just like I always used to do. And, as I was simplifying what happened, but in practice there was real progress being made there. And then about 2016 or 17, then there really was a sea change. And in my case, the personal anecdote is that I had a very, very good postdoc, Jose Hetzever, and I think he wouldn't mind me saying it, he probably didn't know an awful lot of computer science. I certainly didn't. And he said, this is a routine search operation we do in gravitational lensing, which we heard about this morning. And it's a big, it's a big job to do it. It's certainly not very sophisticated. It just takes a long time to look for things. And he says, I can do it a million times faster using some algorithm I don't understand that a friend in computer science has given me. That's a million times faster. Now you might say it wasn't terribly good code to start off with. That's almost certainly the case. But this was a sea change. It was absolutely clear. And he dragged me into a couple of papers we wrote about 2017, I think it was. And it was clear that this was a very big change in the practical business of doing data analysis and doing in the sort of science I know about. And obviously the particle physicists using torrents of data from CERN have known this too, and they have seen the experience. So in that way, I think it has had a huge change. In terms of my transition to a slightly different topic, in terms of my own teaching, I'll go back to sort of symbolic manipulation and so on, in particular things like Mathematica. There are other equally good proteins. And I was sort of present at the sort of inception of those, the earliest symbolic mathematical programs. And we used to have contests to see which was the most elementary thing it would screw up. And they were learning. Now it's magnificent. I mean, both as a tool for doing research. I'll give you one example, which somebody mentioned gravitational radiation. There's a famous thesis that was written about how to calculate the gravitational radiation for a binary star in elliptical orbit, and it was a tour de force at that time. I can get the right answer as was calculated in 4 lines of nested computer code on Mathematica executing in 1 second. And that just shows you what the transformation is. And so what does that mean for my teaching? That means instead, when I learned general relativity, there were nights of computing Christoffel symbols by differentiating this and differentiating that and making mistakes and another cup of coffee to find where the sign error was, etc., etc. Now, that's all outsourced to symbolic manipulation, and I can spend the time actually discussing the fundamental principles, why we do this, what is being assumed here, and is it correct? Then I think that's actually a great boon to teaching. Now we've heard it's the tree of the knowledge of good and evil, and there's certainly a downside there. There are many, I think, challenges that it is putting in front of educators for sure. But I'll stop at that point and talk on.
I think from what Professor Blanchford told us just now, I think maybe being able to distinguish what AI is good for and use it for what it's good for can help us save time so that we can spend the time meaningfully on something else, maybe on checking the accuracy of the results from the AI analysis or teaching, or maybe using the time to dig deeper into the problems to understand more science. Those are some of the things that we can start thinking about. So at this point, I also like to encourage our students and members of the audience to raise any questions you may have. With that, maybe we will start with a question by that gentleman first. Thank you.
Hello, Tamim from Interesting Engineering. I have a quick question because there have been debates of AI getting senile. Over 1 year, there are many stories we're hearing about how senile AI would get. So, as per your understanding and research, how far are we from achieving AGI, and how threatened should we feel? Thank you so much.
Can you repeat the question? So we cannot hear very clearly.
How far are we from achieving AGI, artificial general intelligence, or have we already achieved? It's a constant debate. So how threatened should humanity feel if such a thing happens?
Again, I couldn't hear something. AGI, artificial general intelligence.
General intelligence.
Artificial general intelligence.
Yeah, maybe for the audience, if not, and also at least for me and some others, maybe you could give your operational definition of AGI.
There has been constant debate, if you could look up online also, from last 1 year, that possibly there was a scoop last year that ChatGPT 5 may come up, and then they stopped because the potential of reaching AGI could be dangerous to humanity. So that's what my question is. Should we feel threatened by the axle of AI, artificial general intelligence?
I think there is, to the extent that it's intelligent, if you play with GPT-4 based ChatGPT, you feel you're having a kind of intelligent conversation. In mathematics, when you get beyond somehow summaries of introductions and so on to the actual structure, it suddenly begins to lose sense. But for a while, you have an intelligent conversation on arbitrary subjects that were not built in. So I think, something is happening there, it seems to me. General intelligence as opposed to some artificial intelligence attempts to, have a program that can converse only about traffic or something like this. Yeah, it's clearly general, right? It's the description of how, at least from what we're told, the description of what you do is very, very, very simple. It's not, there's no knowledge built into it. So, yeah, I don't know anything about the risks that it poses to humanity or anything like that, but it seems to be, based on a new, very, very simple concept. In some sense, it's based on masses of data that are already in the internet, but the way to interpolate that into a new answer is completely new.
I think if I understand the thrust of your question, should one be anxious and vigilant? I think the answer has to be yes. In the news there's been an international government panel, including representatives from China, meeting in Bletchley Park in England, and within the last month. And they issued, there are experts and politicians and so on, and they issued communiques saying, you should be alarmed not be alarmed, but you should be vigilant. I'm not quite sure what the language they used. And I think the message I got from discussions like that and others was that you have to think about these questions not on the sort of slow progress of the law or politics or academic life, but more as on a wartime scaling, in the sense where you have to react extremely quickly because changes are happening in the commercial and international and government and so on so fast that you have to be you have to be able to respond very quickly and understand what's happening, and if necessary, if some action is needed, preferably internationally, then I think people have to be worried about it. And that's a general concern about where AI could be taking us. I think him more concerned about the impact on education. Those are very much larger issues, but I think the impact on education is still raising enormous challenges for teachers everywhere.
Questions from...
All right, thank you very much. My name is Yudi. I'm a PhD candidate in mathematics and statistics from the University of New South Wales in Sydney. I think as academics, we have a lot of authority on what gets taught and what doesn't get taught, at least say in undergraduate level. So maybe the best way for me to ask my question is to use a concrete example in mathematics, but I'm sure there are analogous situations in other disciplines. Let's take something very simple like multiplying matrices. We teach that to first-year undergraduates. Some might argue that we don't need to do that anymore because symbolic algebra packages can do that, and maybe now we say ChatGPT can do that as well. And some other people might argue, well, if they can't even do that, how do we expect them to be able to think? I guess some people argue we just skip to the point where we teach people to think. And some people will also argue that well are those independent skills? And then maybe I'll stop the arguments there, but how do you feel about this? Where do you think we should stand?
Yeah, go ahead.
All right, I'll give a shot to that. Let me take that specific example. Should you teach at whatever stage it's now appropriate to do the multiplication of, say, two by two matrices? My answer would be yes, absolutely. And to see how to do that, should you consume night after night of a student's life doing routine operations? The answer would be no. So I think it's the fundamentals that you need to put more and more time into it. And I think Professor Cohen mentioned the sort of decline of I would say, numeracy in some sense, an awareness of what numbers mean. And I think that's a more general concern of that decline. And I think part of addressing the challenge and the opportunity of these new approaches, which you could call AI, is to at least trying to keep abreast with what's going on. And I would say, I think I've worried for a long time that education has been too fixated on how you teach and the techniques that are used. It's important for sure, and one shouldn't do any less of that. But the issues of what you teach, how you assess it, and we're talking about exams. Exams are very important in Hong Kong, I know. So and I think and the third thing I should say is how well what you teach is retained. Is it still there in 5 years' time? And I think we need equal efforts to get our heads around those three issues. We needed that, and now it's become a much more urgent business, all three questions. And I think universities in particular, but people working in high schools and so on, and those who decide high school curricula ought to be paying much attention to those three issues as well as the how to teach business as well. That would be my answer to your question.
That actually reminds me of what I learned when I was a student, because at the time a lot of people are doing numerical simulation, and when you're doing numerical simulation, you can almost get any results in any situations. But sometimes you're not really sure whether you can believe in the results from the simulation. And knowing some of these fundamentals, you can check or you can have a sense of whether the results make sense or not. And maybe a little bit of what ChatGPT, generative AI, what they give us can be a lot of information and can be a lot of results that are very exciting. But if we don't have the ability to tell whether the results make sense or not, then it becomes more dangerous. Yes, more questions from the audience? Maybe this gentleman in the front first, or yes, please, yes.
So I have a more down-to-earth question. So when you discuss AI and in education, I basically heard about ChatGPT and other large language models. Do you have any ideas how to use other developments in AI for teaching? I know Stable Diffusion comes to my mind, maybe text-to-speech models, and presumably, I know, reinforcement learning for, grading students.
Yes, actually, in addition to ChatGPT or Stable Diffusion, we have many others to use. Like, there are more and more startups in the world, and they are producing very exciting new products that we can help us. Let me give you one example. Like, for example, the Middle Journey, for example. It's a startup in Bay Area, and you can try to use Middle Journey, and many others. We can use for inspiring the students.
Maybe in future you start by asking ChatGPT which generative AI model you should use first. Maybe that lady at the back.
I am Sowaporn from Bangkok Post. I didn't have any scientific or teaching background whatsoever, but the situation on AI in Thai is we have a problem a lot on the art side that we tended to confusing. We tended to say that okay, AI is normally plagiarize the work in the work in art and in humanity way. My question is there any such a problem in a scientific field? And if so, as a teacher, how to prevent the freshmen like 18 and 19 years old who didn't know anything about your field to prevent them from that kind of plagiarizing and unreliability of the AI. Yeah.
So I guess this question is about plagiarism and AI, and I'm not an expert on this field. My feeling is that probably plagiarism may need different definitions of the different scenarios with AI arriving. I remember talking to some colleagues. Some colleagues were saying that if there would be plagiarisms, whether there's AI or not, there would be plagiarisms. There are just different ways of plagiarizing, so it's more important to teach students not to plagiarize. But of course, maybe with AI, there will be new meaning, new measures as well. Maybe our panelists can share some of your thoughts on this as well.
Why don't you give us?
I don't have really I don't have any experience with the question of plagiarism as such. And in fact, I think my university pays exaggerated attention to this issue a little bit. I mean, it exists, but it's very marginal. But I'm interested in something which is in some ways similar, which is in fact about the ability to look up everything instead of having to think yourself. Yeah, so not necessarily in an exam situation. And this already is very marked as a contrast between my generation and the generation of my students right now. And I'm thinking about graduate students, about people that you want to do research eventually. So when I was a graduate student, I had to think about things, and maybe 95% of my thinking time was wasted because I was reproving known things, right? I saw a path towards some question, and I tried to think about it, and on the way I need to settle first some smaller issue, but it's not that easy to go to the library and find out whether anybody discussed it before. Probably yes, yeah, but you have hundreds of thousands of papers. And today, so I thought about it myself, and this one would take a week, and this one would take 2 weeks, and in the end, yeah, they don't get into any paper. They don't get into your PhD because you find out, when you finally know what concept it's about, you find out someone already did it. Was it a waste of time? I don't think it was a waste of time at all, because you appreciate these concepts in a completely different way when you're forced to largely do them yourself. Now, for my students, it's an almost impossible temptation to resist to first look things up. And you have many sites in which, it seems everything's been asked already, and you wonder about something, you ask it, Google search finds it, and it was done for you. I think it's much harder today to develop the skills to think about a new problem. I don't have a solution to it, but this was already a problem under Google, and it'll become much more, now there's more efficient ways of searching, and it'll probably be a problem as well.
I think I'd agree with that, and I can I think I can see the dangers already in the students I encounter, that because you're able to so easily access what already exists, you're less inclined to try and think it through in an idiosyncratic way, which might be rather inefficient, might be a rather poor outcome, but can sometimes over a period of time, be very helpful and will help you solve some other problem down the road because you've developed your own pattern of thinking. And if you look at the sort of innovators, if you were in physics and astronomy and the parts of mathematics, I think I know some little experience with, is they by and large have had that experience of having to think through things for themselves, even if they have done it in a not terribly useful way. Still, it's planted a seed which has blossomed at a later time. And so we might be denying our students that opportunity in some sense if we're not careful. And again, I think we're looking at, you know, a future that which we have some control over, and we should try and, you know, keep up with it as best we can. I would say that again. There's one other aspect that sort of comes up a little bit with this, and it's not just the sort of algorithmic or the subject matter of science. There's also a very human aspect to this. And COVID, perhaps one of the very few benefits of COVID, and there are many opposites, but was that it performed a perhaps relevant experience of how important having human beings in the teaching process was concerned. Do the high school students of today, for example, have they been as well served by Zoom and depersonalized education of one form or another relative to having a human being interacting with them in a very human way? Do students need that at an undergraduate level, high school level, or whatever? And I think the general experience has been, and some in the audience may disagree with this, is the answer is yes. Having the human being there really is a qualitatively different experience. It isn't to say that learning through the internet or whatever, or the World Wide Web, isn't part of what's going on, but still there's a vital human role there. And I'd be curious to know what other people think about that.
I think maybe before we move on to another questions in person here, there's a question online. Maybe we can answer one online first. I am actually a supporter for using AI for learning and research. AI will be an indispensable tool for us in the future. Do you think the most important thing now is for us to teach students how to use AI correctly and cite work done by AI properly rather than banning it? Thank you. Thoughts on that? This is the question from online, yes.
Online. Yes. So can you briefly repeat the question?
Okay. Yeah. Right. The question has been deleted just now. So basically asking, I mean, do you think the most important thing for us to do now is to teach students how to use AI correctly and cite work done by AI properly rather than banning it?
Oh, I don't think so. So AI, as I said, is just a tool, or it's some very useful tool for us for teaching, but it cannot replace teaching. I mean, the traditional way of teaching, like just one of our speakers mentioned, you still have to know, you still have to understand the fundamentals in mathematics. Okay, AI can give you the answer of the result of the multiplication of two matrices, but AI cannot teach you how to understand the logic, right? So you still have to understand how this works and how this doesn't work. So, and then you can understand, you can really understand, what you are learning, instead of just getting the results immediately, conveniently, free, right? But you still have to understand the essentials.
So in the interest of time, let's have our final questions. Any members from this side? No question. Maybe this gentleman in the front, because I think he has been raising the hand for some time. Thank you.
Thank you. I'm Lester, a high school student from Hong Kong. I mainly want to ask, like maybe in the past we get information from reading books, and then now we Google a lot and we have a lot of search entries. But now as generative AI, particularly those that use LLM, is more common, we actually, when we ask a question to ChatGPT, it gives us a very linear answer. Like there's like one response with mainly one direction. Sometimes it breaks it down into like say 10 points, but it's still one major direction. As opposed to maybe in the past when we read books or when we Google, we have a lot of different results that might vary a lot in terms of their directions. How do you think that will affect our learning and affect our exploration and discovery? Thank you.
Okay, let me take a shot at that. I think there's an old-fashioned school of science education is you've got to learn lists, and you learn lists of geological eras or something like that, and I think most of us here would say, no, it's not about that. It's not about, or learning a list of techniques for doing integrals, for example, A, B, C, D, E. It isn't about that. It really is a lot more about learning a system, learning ways to adapt and expand it. And the key to that, for me, I'll just say for me personally, people learn in very different ways. People learn visual, from listening, people learn from reading and so on, but people learn in different ways. But for me, very much, a lot of it is concerned with organization. And you've got a body of knowledge, let's say quantum mechanics, you've got a body, it's a big business, quantum mechanics, there's a lot to learn there. And there's many different aspects of it. It veers off into lots of different directions, condensed matter physics, particle physics, and so on and so forth. And learning it, a key is not doing one homework problem after another. It's about getting the organization right. And that is where the good book helps an awful lot. The good book that's thought through and has an organization, makes the connections, has a logical structure that you can keep in your head. And then, the old truism, I think it's true of many sciences, but I think I particularly associate with physics. The more you really understand, the less you have to remember, the less you have to sort of keep, as some sort of list. If you really understand it, then what follows comes from that much quicker. And there again, I think the book really is important for that. Where the students who must have a different perspective will agree with that, whether I think we're going to find out, but that would be my view.
I also echo what Professor Blandford just mentioned. I think as educators, one of the important things that we have to realize is that every student is unique. Every student maybe learn very differently. So if there are more different ways that students can use as a platform to learn, it may benefit some students who were maybe less effective in learning using some older and conventional platforms. So my hope is that with more different tools to facilitate learning science will become more widespread, and more students, more citizens are able to learn different subjects in science and be able to develop their interest and their ability in science. So that's how I look at some of these platforms that are becoming available as well. Yes, please.
It's coming.
Nope. Hello? Is the mic on? The mic's on. Very good. So listening to this conversation, something that strikes me is, I think almost everybody would agree that when you learn to play a musical instrument, you have to put in the practice. And to become a truly excellent violinist, the statement is usually you need of order 10,000 hours of practice spread over a number of years. And I think there's something similar about learning to do science too. And that learning, I think a lot of it is exactly what we heard about working out for yourselves problems that other people have solved. That's like doing these studies that violinists do, or playing scales, developing your ability to do this. And once you've done this, and you've become a good violinist, then you can read the music straightforwardly, and you kind of feel what should come next, and you see the pattern of the music, and you can play it. And I think doing science is not so different. So I think there isn't a fast route to getting there. You have to put the work in to learn the techniques, to internalize it so it becomes part of you, and you see the way. And so I think if there is a danger, it would be that people think this is somehow an easy solution. I don't think there is one. You really have to put the work in and train yourself so you become the concert violinist.
Great point. I think it's important for scientists to be able to develop that intuition and that intellectual muscle memories.
Questions from the online, so should I read them? Maybe one of the questions is, AI is more and more dominated by industry, such as Google or Microsoft, than academia. What are your thoughts about the role of industry versus academia for science moving forward?
Well, that's obviously true, and it's part of the challenge. I mean, the time scale in, say, in a company like Google, for example, they're not going to spend 3 years studying the problem. They'll move much faster, and that's why I think, for the purposes of this discussion, educators are going to have to be able to respond very much faster than they have been doing over the past decade or so to changes in the environment of their students. Yeah, I would certainly agree with that. And I would also agree with the statement that Simon said. I mean, it really is important to the students realize there's no shortcuts, but they can still develop a good personal organization of what they're seeing. But they do have to do with the scales and arpeggios, absolutely.
So I guess it has been a very lively discussion with a lot of good points that were raised, and I personally learned a lot as someone who is not very familiar with this subject, but unfortunately time is up. But I guess even though time is up, this topic we can continue to discuss for a long time, and hopefully soon there will be more understanding, lessons, and things that we can agree on, so that we can use this as or so that you can move forward, coexisting with the fact that AI will be with us. And with that, please join me to thank our two panelists, Professor Blandford and Professor Hurowski, for giving us very illuminating thoughts and insights, and also my co-host, Professor Xiaoming Yuan. And thank you all for talking to us and giving us your thoughts in the past half an hour or two. Thank you.
Thank you very much, and thank you, Professor Shum, for hosting the session for us. Thank you very much, gentlemen. Please be seated off stage. I mean, one of the things that strikes me that AI so far cannot do yet is to have a passion. And if I were listening attentively enough for the past 2 days, in all of the sessions, I do feel the passion, the inquisitive nature and curiosity coming across in all the sharing sessions. And particularly, I would like to have a big shout out to those of you who have raised questions, posted questions to our panelists today. Your questions have made this so much more interesting. So once again, a big thank you to our panelists for the afternoon. Let's put our hands together once again for them, and for Professor Andrew Cohen for doing us the honor of having a great sharing, educating us. In the meantime, thank you so much. And thank you all for joining us on the live webinar.